Hello, Professor. Here's my question 2, part E, simple code. I've been using the W3 Schools editor. I probably should have mentioned that in my previous video, but I figured you were probably already familiar with this editor. It's an in-browser editor, and it says try it, so I guess it's supposed to be sort of a demo, but it does give some debug feedback. So while it doesn't have all the features a typical IDE has, it does give some debug feedback, and that's really all I need. And it's really nice that it doesn't drag my computer so bad, although it used to not have ads, and for some reason now it does. Anyway, so let's begin. I will show a demonstration. So it's me clicking the run. You can see it loads up. And we've got everything we've asked for here. I started off, I provided the documents, training, test, and printed them out. And for part A, tokenize, which is a very simple, well, it's 3 different things going on here, but it's a nice one-line command. When we call text, that's going to get rid of the punctuation. Lower for lowercase, split to split them up into tokens, which ignores the based on white space, so we don't get the white space captured, so that's nice. Well, this is me printing that out, but the return is the same, as you can see. So the vocab is a set. I talked more about the vocab down here. If I can find it. Oh, here it is. So I was having a really hard time for a long time. I was trying to just add words to the vocab, and it seems like it should be a simple operation, but when I use the basic parenthetical or the basic brackets, it was allowing me to add duplicates. So obviously we don't want duplicates in our vocab. So that's why we're going to provide a set. And that is all of part A, is just tokenizing. You can see here's the tokens. Really just splitting it up into one word at a time. Pretty straightforward examples. Part B, we need to compute the prior probabilities. So I've created a variable called classes, and this is a dictionary of dictionaries. Pretty interesting, right? So we have a positive dictionary and a negative dictionary inside a dictionary of classes. I think that's pretty cool. Then we have counts. I tried initializing counts as a few, well, I was going to say a few different data types, but I guess I tried using an array and an integer, and eventually I settled on the dictionary for counts as well. So I already talked about this note here. I tried the different approaches with the vocab. So we're iterating through. This is kind of just set up to get all our counts and our labels and counts of the labels and how often they appear together, to get all that squared away so we can actually perform the calculation. Same thing here, we're getting ready to perform our prior calculation. It's needed right here. I noted that there. Oh, rolling right along. I guess I'll show that. Let's go ahead and show you that this is a live run one more time. So you have classes, positive, I love this movie, great, negative, hate this movie, is terrible. prior probability, 0.5, 0.5. So let's show what we're doing with the add one smoothing. I really like the add one smoothing because I think it just doesn't make any sense to have zeros in your document. As you explained in the lecture, there are always going to be examples outside of our training set that we've never seen before. So it doesn't make any sense to have a zero. So here's our part C. We take the label and the word count, and for a lot of my summation I did for loops like we are taught very early, but eventually I realized that a sum would be a lot more efficient and straightforward, so that's really a lot easier, although a for loop's not hard either. And we are going to go ahead and for loop here, words and vocab, words not in word count. And then we're performing our calculation that's been provided to us here. So this +1 right here is the smoothing, and that's how we make sure we don't get zeros. Really nice, really like that. Okay, and finally we just got to log 10 everything and do a little more calculation. Dictionaries have keys. Again, the dictionary, it's really nice so you can combine a string with the different counts of the strings. So by having those counts there and then calling the dot keys, it's very easy to call that. So we'll figure out our log probability using log 10 as discussed. And it's a lot easier to perform these log calculations via Python than it is by hand. Although it wasn't too bad by hand, just kind of have to write everything down. I had a probs variable, but I guess I could have made this probs2 probs, and then same probs3 could probably decrement that. But so we do our calculation on the logarithms, sum everything up, and return. So then lastly we finally get to classify. Probs feed the doc to probs3. And then when we max the value, it's the same thing as in the written portion. When we compute, we add up all the logarithm values on each side, and then we figure out which one is greater than the other, the negative or the positive. That's the last step that's going on here as well. Max probs3 is going to return whichever one is higher, positive or negative, and then the key equals probs3.get is going to give us, of course, the string that holds that value. Thank you.